Hello class, this is section 3.3, circular functions. So let's take a look at this section. So for this first example, they want us to find the 6 trigonometric functions of the angle 5, 6 pi. Well, 5, 6 pi is right here, and it's got coordinates negative radical 3 over 2 comma 1/2. So given that information, we should be able to find the 6 trig functions. So the sine of 5, 6 pi is the y-coordinate. The y-coordinate is 1/2. Cosine of 5, 6 pi is the x-coordinate. The x-coordinate is negative radical 3 over 2. Tangent of 5, 6 pi is y divided by x. So we can do y divided by x, which means multiply by the reciprocal. And you'll get the 2's to cancel out, and you'll end up with negative 1 over radical 3. And then the reciprocal functions, that would just mean that all we need to do is take the reciprocal of those ratios. So that would be 2. Secant of 5, 6 pi would be the reciprocal of cosine, which is negative 2 over radical 3. And you can choose to rationalize that if you'd like. Cotangent is the reciprocal of negative 1 over radical 3, which is negative radical 3. So that's how you find the 6 trig functions of that angle. For the next one, they're asking us to find tangent of t. Well, we know tangent of t is equal to y over x, and we have y and we have x. So all we got to do is divide these two numbers, and that should do it. So if you divide, you should end up with 0.675 divided by 0.737, which is negative 0.915. If you round to 3 decimal places, that would round up to a 6. That would do it. All right, now let's move on to the next example. So they're asking us to evaluate sine of 9 pi over force. They want us to identify the function, the argument of the function, and also the value of the function. So there's 3 things we need to identify. Let's start off with the function. The function is sine. All right. The argument is what you're taking the sine of. In this case, it is 9/4 pi. All right, and now the value is when you actually evaluate that. Well, this angle is greater than 2 pi, so what I like to do is I like to subtract 2 pi to find a smaller coterminal angle. And my LCD would be 4. So that's going to be 9 pi, take away 8 pi, which is 1 pi. So now we have the coterminal angle of 9/4 pi is pi over 4, which you can see by this diagram here, this figure. These two angles are coterminal. All right, so now all we got to do is find the sine value of pi over 4. Well, we know the coordinates from our unit circle are radical 2 over 2 comma radical 2 over 2. And since we're looking for sine, that would be the y-coordinate, which is radical 2 over 2. So that would be the final answer. Well, there's 3 parts to this question, so those are the 3 answers. And that will do it for this section. Let's move on to the homework. Okay, for the homework, these are just fill in the blanks, definitions. Let's look at this first question. Use a unit circle to find all the values. Notice they say all the values. That means there can be more than one. There can be more than one that are between 0 and 2 pi. And then we'll separate our answers using commas. All right, so on our unit circle, we know that there's 2 angles whose cosine value is negative radical 2 over 2. And you should be able to find those. Cosine is negative in these 2 quadrants, 2 and 3. So the 2 angles are going to be this one and this one. And they want radians, as you can see. So this angle would be 1/4, 2/4, 3/4. 3/4 pi is one angle. And then the other one's going to be 1/4, 2/4, 2/4, 3/4, 4/4, 5/4. So 5/4 would be the other angle. All right, now let's look at this one. It says if angle theta is in standard position and the terminal side of theta intersects the unit circle at this point. Well, that's positive, negative, so that's going to be quadrant 4. So your positive 1 over radical 10 minus 3 over radical 10. So our angle is going to be around here somewhere. So I'll just draw it around here. All right. So they're telling us that the coordinates are 1 over radical 10, comma, negative 3 over radical 10. And they want us to find sine. Well, because we're dealing with the unit circle, sine is just the y coordinate. So that would be negative 3 over radical 10. The cosine is the x coordinate, positive 1 over radical 10. And then the tangent is y divided by x. So y divided by x is the same as multiplying by the reciprocal. And then we're going to get this to cancel out. And so we're going to end up with negative 3 as our final value. All right. So they want us to use this figure below, which shows a unit circle with increments of 0.1. So this is 0.1, 0.1. Each of these increments is 0.1 of a unit. And we're going counterclockwise, which is that direction. And they want us to estimate the secant of 4.9. So the first thing we need to do is figure out where 4.9 is. Where here's 1, 2, 3, 4. 4.1, 4.2, 3, 4, 5, 6, 7, 8, 9. So here's 4.9. So we can locate that by going right there. All right, so cosine, cosine is the x-coordinate. So the x-coordinate, this is right between 0 and 0.4, so this has to be 0.2. So that's the x-coordinate of this point right here. And secant is defined as 1 over cosine. All right, so in other words, we need to find the secant, or we need to find the reciprocal of 0.2, because that's the same thing as finding the cosine of 4.9. I'm sorry, let me rephrase that. So secant of 4.9 is the same thing as 1 over cosine of 4.9. Well, we know that the cosine of 4.9 is 0.2 because we just found that out. It's right in between 0 and 0.4. So what we're looking for is 1 over 0.2, which if you do on your calculator, 1 divided by 0.2 is 5, is our final answer. All right, identify the argument. Well, this is the argument. The argument is what you're taking the sign of, in this case, which is x plus pi over 6. Everything in the parentheses is the argument. Use a calculator to approximate the value to 4 decimal places. Notice there's no degree symbol here. Since there's no degrees, you need to be in radians. So change your calculator to be in radian mode. Once you're in radian mode, then you can just enter the sine of 6, which is equal to negative 0.2, and they want 4 decimal places, so 2794 would be the answer that I get on my calculator. If we start at 1, 0, that means you're starting over here. You're starting here at 1, 0, and you travel once around the unit circle of 2 pi and arrive back where we started. And if we continue around the unit circle a second time, we'll repeat the values of x and y that occurred during our first trip. Use this discussion to evaluate the following expression. So notice that 2 pi is 1 complete revolution. So if you start at 3/2 pi, which is here, and then from this point you go 2 pi, that's 1 complete revolution, you're just going to end up where you started, which is here again. And since we're looking for sine, that would be the y-coordinate of this angle here. So that's 0, negative 1. So the y-coordinate is negative 1. All right, determine if the statement is possible for some real number z. Well, pi over 2 is 90 degrees. which is here. That has a coordinate of 0, 1. Secant is a reciprocal of cosine. Cosine is 0. So the reciprocal of cosine is 1 over 0 in this case, which is not possible because that's undefined. Determine if the statement is possible. The sine equal to 1.4 would not be possible because sine, the way sine, the function that the graph of sine looks like this. It's a sine wave. It just oscillates between 1 and negative 1. Oops, that's positive 1. This is negative 1. So the graph oscillates between 1 and negative 1. It never exceeds 1 or never exceeds negative 1. It's going to be always between those two values. So it's not possible for sine to reach 1.4. It's just not possible. So that's the second choice there. So they give us a diagram here, and they want to know what happens as theta, if theta is close to 0. So imagine this angle here. If this gets smaller and smaller, then this triangle is going to it's going to look like this. The smaller theta is, the more and more it'll look like this. Right, so that's what's happening here. All right, so now what we need to figure out is what happens to sine theta as theta gets close to 0. So sine theta is given by opposite over hypotenuse. Hypotenuse is 1 because this is a unit circle. So it's just going to be this red line is what sine ends up being, because opposite over hypotenuse is where hypotenuse is just 1 is always going to be the length of that red line. So if this angle gets smaller and smaller, this side is just going to get smaller and smaller, and it's going to get closer to 0 because this red line is going to get shorter, 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 and shorter. So it's going to get closer and closer to 0. What happens to cosine of theta as theta gets closer to 0? Well, cosine is adjacent over hypotenuse. Since hypotenuse is 1, it's just going to be the length of this blue line. So once again, as theta gets smaller and smaller, as you can see, the blue line is going to get longer and longer, but it's going to be contained in this circle, which the maximum value that it can take is 1. So the smaller that theta gets, this just gets longer and longer and longer and longer, but it cannot exceed 1. So it's going to get closer and closer to 1. All right, tangent is given by sine over cosine, so this over this. Imagine this gets really small, close to 0, and this gets longer, closer to 1. So 0 divided by 1 is going to get closer to 0. So that should be close to 0, which it is. All right, cosecant. What happens to cosecant? Well, cosecant is 1 over sine, right? The reciprocal of sine. So if sine is getting smaller and smaller and smaller and getting closer and closer to 0, well, the reciprocal of sine is cosecant. So cosecant is equal to 1 over sine, but sine is getting closer and closer to 0. So therefore, this is going to get closer and closer to 1 over 0, which means this is going to get infinitely larger. So it's going to become increasingly large. It's going to approach infinity, actually. If you take values 1 divided by very small values, not equal to 0, you're going to get really large numbers. So that's going to approach infinity. And secant, well, secant is cosine is getting closer to 1, we said. So 1 over 1 is going to get closer to 1. And finally, cotangent is cosine over sine. Remember, cosine is getting closer to 1, sine is getting closer to 0, which means that's going to approach infinity again.